So this is Unit 8, Liquids and Solids. The kinetic molecular theory of liquids and the kinetic molecular theory of solids are in the foldable, so make sure that you complete the foldable and look at the properties discussed on the foldable and know the differences between those properties in reference to solids, liquids, and gases. So you're going to have to remember some things from Unit 7. There's two types of solids. There are crystalline solids, which are very ordered, and there are amorphous solids, which actually have no fixed shape. So if we look at our pictures, down here at the bottom, we have sodium chloride. So you have chlorine, sodium, chlorine, sodium, chlorine, sodium. It's a very structured, there's a pattern to it. So that is a crystalline structure. An amorphous solid is like the SiO2 here. We don't have a specific structure to it. None of the circles are identical. So there's no fixed shape, so it's an amorphous solid. There are two amorphous solids that you need to be aware of, and that are those are our plastics and glass. Both plastic and glass are amorphous solids. Phases. Phases exist in equilibrium. In other words, we have two phase changes occurring at the same time, and they're opposites of each other. So in my glass of water, I have ice turning into liquid water. So I have solid going to liquid, and we call that melting. But at the same time, some of my liquid hits the cold ice cubes and goes back from liquid to solid, which we call freezing. So I have the two opposing changes, melting and freezing, occurring at the same time. So my glass of water is at 0 degrees Celsius until everything turns to a liquid or everything turns to a solid. Then the temperature can change. So equilibrium, we have these two opposing phase changes occurring, and the temperature remains constant until everything changes to one phase. So all of our phase changes happen in these pairs. As you go from something very ordered to something very random, or you go from random to very ordered, you have a change in energy. If you have to add energy in, then it's endothermic. If energy is removed, it's exothermic. We've known those two vocab words since Unit 1. If you are creating disorder, if it's becoming disordered, then it's endothermic. So as we move from solid to liquid to gas, it is an endothermic process. As you become more ordered or less random, then it's an exothermic process. So as you go gas to liquid to solid, it is exothermic. Now a phase diagram represents the pressure and temperatures of our different phases and how we can change pressure and temperature to create our phase changes. So the area that's next to the x-axis is always our solid area. The area next to our y-axis is always our gas area. And the area that's in between is always our liquid area. So if we were to move across the line from liquid to solid, we would call that melting. So if we were to start in this area and end in this area, the line would tell us the melting point. If we were to start in the liquid area and go to the solid area, that would be called freezing. So moving from this side to this side of the line is freezing. So the freezing point would occur on that line. Now, if we were to go from the liquid to the gas phase, that would be called boiling. If we were to move from the gas to the liquid phase, that would be called condensation. So it depends which direction or how you're moving across the line to what vocabulary word you're using. If we go from a solid to a gas, that's called sublimation. So we would have to be crossing the line that direction. The opposite would be deposition, going from a gas to a solid. So we would be crossing the line that direction. Now the triple point is where all three phases coexist together. So right here where our three lines meet, that is the triple phase. Or I'm sorry, the triple point. So at that temperature, at that pressure, you would see the solid, the liquid, and the gas of that substance together. The critical point is where you can no longer be a liquid. So that's the point where the liquid to gas line ends. So you'll be asked questions like at 5 atm and 5 degrees Celsius, what phase are you? And so you could say, well, at 5 atm and 5 degrees Celsius, I'm a solid. If I was to increase the temperature to 20 degrees Celsius, what phase change would occur? I would say melting, because I'm going across the liquid, solid liquid phase line that direction. Another question is, what is the normal melting point? Well, normal means 1 atm. Melting means going from solid to liquid. So if I was at 1 atm, I'd come across and I would come down and I would mark down my temperature. So let's say it's 11 degrees Celsius because it's pretty close to 10. So the melting point would be 11 degrees Celsius. The normal melting point, 11 degrees Celsius. If it said, what is the normal boiling point? I know normal means 1 atm, and I know boiling means liquid to gas. So I would just continue my line over till I hit the liquid to gas line, and I'd come down, and that looks about to be 30 degrees Celsius. Molar heat of vaporization. So it's vaporization means going from the liquid to the gas phase. So it's how much heat is needed to vaporize 1 mole of a liquid at the boiling point. How much energy do I need to take my 1 mole of liquid and turn it into a gas? Molar heat of fusion. Fusion means melting, so we're talking about going from solid to liquid. How much heat do I need to take 1 mole of solid and turn it into a liquid? You just need to know these definitions. Our next graph we have is a heating or cooling curve. Now this picture, this particular graph, is a heating curve because we're going from a colder temperature up to a higher temperature. At a colder temperature, you would be a solid. In the middle temperature range, you would be a liquid. And at the highest temperature range, you would be a gas. So if you went from solid to liquid, we would call that melting. But if you went the other direction, liquid to solid, we would call that freezing. So there's 3 diagonals to represent our 3 phase changes. The 2 plateaus or flat portions represent our phase changes. So both my melting and my freezing for this substance is happening at 10 degrees Celsius. Now if I look at the other plateau, I'm going from a liquid to a gas, which is boiling, or vaporization, or evaporation. If I go from a gas down to a liquid, that's condensation. So both boiling and condensing happen at 70 degrees Celsius. So you'll need to be able to read off what temperature our phase changes occur at and be able to label the graph.